Hello friends, welcome to my YouTube channel VP Gupta classes. Now we will discuss about the topics which is called potential energy of electric dipole in an external field. And we had also discussed in previous lectures electric field intensity at any point due to a short electric dipole, and also that videos also discussed about the torque acting on electric dipole when kept in uniform electric field. So now we will discuss about the potential energy of an electric dipole in an external field. External field means externally we apply the how much force or torque is applied to neutralize the rotating effect of rotating effect of electric dipole in an uniform electric field. Now we had already discussed about the torque acting on electric dipole in an uniform electric field. Suppose this is the electric dipole which is kept in uniform electric field E, and we assume that the center of electric dipole is A. Center of electric dipole is O, having dipole length 2A. Having dipole length 2A. Since we had already discussed when electric dipole is kept in uniform electric field, then the translatory force on the charges minus q and plus q is 0. Because of its the force on the charge plus q is equal to QE in the directions of electric field in uniform electric field, and it had already discussed in previous lectures, and the directions of these forces is equal to this direction magnitude of this force is also equal to QE but opposite in direction, so the translatory force is 0, and only couple of opposite couple of force is force perpendicular force exists in that two charges, so it rotate, so torque is produced, and expression for torque also derived. Torque is equal to torque acting on electric dipole when kept in uniform electric field is equal to tau is equal to PE sin theta. It had already derived. So this is electric dipole, and it rotates in clockwise. Suppose it rotates in clockwise, means of that this is the 0 force, and it force applied perpendicular to, and this is the inward directions and it upward directions, so it rotates and torque is produced. So we can say now the electric dipole moment is P. Now electric dipole moment is P, and we know that we know that the direction of electric dipole moment is minus q to plus q, and suppose the angles between electric dipole moment and uniform electric field is theta. Suppose, and it rotates in clockwise directions. That means this types. Okay. Suppose how much electric potential energy in an external field. So, due to finding this, we apply the torque. We apply the torque. This is in the clockwise direction, and we apply the force in anti-clockwise direction, and torque apply is in the anti-clockwise direction to neutralize this torque effect. Okay, torque effect, and this torque external torque is equal to this torque, since it neutralize the rotating effects. That means torque neutralizes. We apply the external torque to neutralize this torque, so the tau ext means of that external torque is equal to this torque. Now tau ext, and after applying tau ext, a small work done dw is done, and angle change and angular displacement, and here angular displacement is d theta. This is the d theta. Okay. After applying tau ext, dw yani dw work done, dw work is done by the applying tau ext, then it displace angular displacement d theta. And as you observing that means of that tau is equal to Pe sin theta. That means tau ext is variable. In this case, tau ext is variable. So theta varies. That means tau ext also varies. Now, if we take dw, a small work done, dw is work is done by the a small external torque tau ext. That means tau ext into d theta. This is the formula of work done in rotating objects. In general, we know that W is equal to Fs, and here in this case force, only two couple of force exist, so rotating effect exists, and there is a torque acting on that. So here in the place of force, torque, and in the place of displacement d theta, since d theta tau ext and a small work done, after applying the tau ext a small work is done, then the angular position change through a small angle d theta. So now if we total work done finding if tau ext applied, then theta once become to theta 2, then we integrating with respect to d theta, that is total work done is equal to dw, means of that tau ext is equal to Pe sin theta, okay, d theta. angular position change from theta 1 to theta 2 assumed. Okay, now dw is equal to w, and this is the constant term pe out from the integration parts, and integration of d sin theta and limit from theta 1 to theta 2. Okay, now w is equal to pe, and as we know that integration of sin theta is equal to minus cos theta, minus out of the integration parts, and only exist cos theta and limit from theta 1 to theta 2. Okay, now w is equal to minus pe and minus pe and upper limit minus lower limit cos theta 2 minus cos theta 1. This is, and this is the formula of work done, total work done by the tau ext. Tau ext means external torque from when electric dipole change its angular position theta 1 to theta 2. This is the work done, and this work done is stored as a potential energy. Potential energy. Okay, change in potential energy. Sorry, change in potential energy. Potential energy is not change, is potential energy. That means del u is equal to w is equal to minus pe into cos theta 2 minus cos theta 1. Okay, now if you separate this value, means of that del u is equal to minus pe cos theta 2 minus 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 into minus पॉजिटिव हो जाएगा, and pe cos theta 2. Okay, and this is the del u means of change in potential energy, not potential energy. So this is written as in the form of u2 minus u1, and will it separates in this form, means of that minus pe cos theta 2 minus minus pe, sorry, cos theta 1 या cos theta 1 ना, cos theta 1 minus pe cos theta 1, and you observe that at a particular angles, if we given the data of particular angle theta 1, sorry, theta 1 or theta, then what is the potential energy of electric dipole? Then you observe u2 is equal to minus pe cos theta 2, and this is the u1 is equal to minus pe cos theta 1. This formula is valid from change in potential energy, means of that this potential energy is stored as this, and as you know that what is energy, ability to do work is called energy, and we apply the torque, from assume theta 1 to theta 2, theta 1 to theta 2, theta 1 to theta 2, then we apply the tau ext, then it has now, if it has now potential in some potential energy, and it has some potential energy. Then change in potential energy here exists, and it is the formula for change in potential energy when we applied the tau ext, not potential energy, change in potential energy, and we apply the, and this is the comparing with u2 minus u1, that is it is equal to minus p cos theta. So now we write u2 is equal to u1 is u1 let u let, so u is equal to minus pe cos theta. This is our expressions for potential energy of electric dipole in an external field. Now we write step by step how you write in the examinations. So now we write, now this is the we explain this term, how to find electric potential energy of electric dipole in an external field, and it is a very easy. First of all, you know that the torque when kept in uniform electric field, then translatory force is not exist, and only a couple of force exist, and this couple of force rotates the electric dipole in an uniform electric field. So due to this rotating effect, we suppose tau ext externally apply, then it neutralizes the torque Pe sin theta is equal to tau ext P sin theta. So a small work done tau ext, a small work done dw is done, and the angular position a small changing d theta. So we put this value, since since the tau ext change from theta, it is a variable, so it integrates from theta 1 to theta with respect to theta, then we get a result this types. Okay, now right. How to write this also write in the some minutes. Okay, field. Suppose, first of all, how to write this expression in easy way. First of all, you assume that suppose of electric dipole, suppose an electric dipole of charges minus q and plus q having electric dipole moment p and dipole length 2. Okay, which is shown in the figure. Since we know that when electric dipole is kept in uniform electric field, then it has no translatory force, only a couple of force in opposite direction will exist. So torque is produced, which is given h tau is equal to P sin theta, and due to this torque it rotates, and due to this torque it rotates in clockwise direction. Okay, now you write and work. Due to this torque it rotates in the clockwise direction. Now we applied external torque tau ext is in the anti-clockwise direction, which neutralize this rotating effect, so it is equal to the torque. Okay, means of that tau ext is equal to tau, means of that tau ext is equal to Pe sin theta, and theta is the angle between electric dipole moment and electric field intensity. Okay, now it had explained, and it had explained by me, and it is written. Now it is written. Okay, it had already explained how tau ext is equal to Pe sin theta. Now we consider, now we consider we consider a small work, a small work dw is done by applied external field tau ext and by applying this, a small change in angular displacement d theta. So dw is equal to tau ext into d theta. So dw is equal to tau ext into d theta. Okay, tau ext into d theta. It is the formula of dw, and it had already explained how. Okay, now we assume the total work done is w in changing angular displacement. Work done w is changing, we assume the total work done is w in changing angular displacement of dipole from theta 1 to theta 2. That means we assume when we apply tau ext, then theta 1, we assume theta 1 to theta 2. Here theta 2, theta 1 to theta 2. So total work is given as, okay, total work done is given as total work is given as total work done is given as w is equal to integrations of theta 1 to theta 2, theta 1 to theta 2, tau ext d theta, and w is equal to theta 1 to theta 2, that is it is equal to Pe sin theta into d theta, and work done is equal to, it is out from integration parts, that is theta 1 to theta 2, that is a sin theta into d theta, and as usual you know that w is equal to minus pe into cos theta into theta 1 to theta 2, since the integrations of sin theta is equal to minus sin theta minus cos theta means minus cos theta. If we put the limits, w is equal to minus pe, that means cos theta 2 minus cos theta 1. Okay, now now w is equal to minus pe cos theta 2 minus pe cos theta 2 plus pe cos theta 1. This is the work done by the external torque ext, and this work done is stored as a potential energy. That means del u is equal to, okay, and del is equal to u2 minus u1, and we separate these types, means of that minus pe cos theta 2 minus pe cos theta 1. In general means of that u is equal to minus pe cos theta. You observed from this, okay. When if we have to find the change in potential energy or change in work done by external torque on electric dipole in an uniform electric field, then we apply this formula, and a particular angles, if it a particular angle, what is the potential energy of torque at any particular angle, so we apply this formula E is equal to minus pe cos theta. And how, what is the maximum potential energy of torque, means of that if a maximum potential energy, that is the theta will maximum, and theta will maximum when theta is equal to 0 degree and theta is equal to 180 degree, and minimum, in this case minimum theta is equal to 90 degree, then the potential energy will minimum. Okay, चलिए तो अब हम एक बार हिंदी में फिर से एक्सप्लेन कर देते हैं इसको। आज हम लोग इस सारे लेक्चर्स में हम ये देखे कि जो इलेक्ट्रिक फील्ड, जो पोटेंशियल एनर्जी होता है इलेक्ट्रिक फील्ड और इलेक्ट्रिक डाइपोल का, वो कितना होता है बाय इन एन एक्सटर्नल फील्ड। तो सबसे पहले तो हम ये किए कि एक इलेक्ट्रिक फील्ड इंटेंसिटी ले लिए, यूनिफॉर्म इलेक्ट्रिक फील्ड इंटेंसिटी, और इसमें एक हम क्या रख दिए, इलेक्ट्रिक डाइपोल रख दिए। और जैसा कि आप जानते हैं कि इलेक्ट्रिक डाइपोल जो होता है यूनिफॉर्म इलेक्ट्रिक फील्ड में, क्या होता है कि इसका ट्रांसलेटरी फोर्स जो होता है वो क्या होता है, जीरो होता है, और क्या होता है कि अ कपल ऑफ फोर्स लगता है, परपेंडिकुलर कपल ऑफ अपोजिट परपेंडिकुलर फोर्स लगता है, जिस कारण से क्या करता है, रोटेट करता है। पिछले ही वीडियो लेक्चर में हमने बताया है। तो इससे एक टॉर्क प्रोड्यूस होता है, और इस टॉर्क की वजह से क्या करता है, रोटेट करता है। तो सपोज करते हैं कि एंटी क्लॉकवाइज डायरेक्शन में क्या कर रहा है, रोटेट कर रहा है, ठीक है ना। तो हमको एक्सटर्नल एजेंसी के द्वारा कितना इलेक्ट्रिक पोटेंशियल एनर्जी स्टोर्ड है एक्सटर्नली, वो हमें फाइंड करना है कि कितना इसके अंदर पोटेंशियल एनर्जी है। तो फाइंड करने का एक तरीका ये है कि इससे हम बाहरी से क्या करेंगे, एक्सटर्नल फोर्स लगाएंगे और इस रोटेटिंग इफेक्ट को क्या कर देंगे, रोक देंगे। क्या करेंगे, रोक देंगे। तो हमको रोकने में कितना फोर्स लगाना पड़ेगा, कितना वर्क डन करना पड़ेगा, जितना कि यह रोटेटिंग इफेक्ट से घूम रहा है। तो हम मान लीजिए कि टाउ ई एक्स टी लगाए, जो टाउ को क्या कर दिया, न्यूट्रलाइज कर दिया। क्या कर दिया, न्यूट्रलाइज कर दिया। और हम ये कहें कि टाउ ई एक्स टी लगाने के बाद इसका जो एंगुलर पोजीशन था, हम एक एंटी क्लॉकवाइज डायरेक्शन में टाउ ई एक्स टी लगाए, तो एंटी क्लॉकवाइज डायरेक्शन में लगाए तो स्मॉल, हम सपोज कर रहे हैं कि स्मॉल वर्क डन हुआ डी डब्ल्यू, और इसका पोजीशन चेंज क्या हो गया, थीटा से डी थीटा चेंजिंग हुआ। डी थीटा हम चेंजिंग कर दिए उसको, और डी थीटा करने के बाद ये क्या हो गया, न्यूट्रलाइज हो गया। सपोज करते हैं तो ये क्या हुआ कि न्यूट्रलाइज हो गया। तो वही हम शुरू में लिखे थे कि जो यहां पर डी डब्ल्यू जो हो जाएगा वो कितना हो जाएगा, डी डब्ल्यू इज इक्वल टू टाउ ई एक्स टी इंटू डी थीटा। नहीं, अब हम जान रहे हैं कि दिस इज, ये जो है किस पर डिपेंड कर रहा है, थीटा पर। यानी जितना थीटा में चेंजिंग करेंगे वैसे ही टाउ ई एक्स टी ये भी वेरिएबल होगा। थीटा पर क्या कर रहा है, हमको यहां से यहां लाने में, छोटा वर्क डन करने में हम सपोज करते हैं कि न्यूट्रलाइज किया। लेकिन अगर हम थीटा 1 से थीटा 2 ले जाने में, मतलब थीटा 1 से अगर थीटा 2 ले जाते हैं तो टोटल वर्क डन हुआ करने में, न्यूट्रलाइज करने में। तो टोटल वर्क डन के लिए हम क्या करेंगे कि वो जो छोटा वर्क डन डी डब्ल्यू निकाले थे उसको हम क्या कर देंगे, इंटीग्रेट कर देंगे। कहां से, थीटा 1 से थीटा 2 तक। और वो जो आपका एक्सप्रेशन आया, ये जितना करने के बाद आया था पीछे पीई कोस थीटा माइनस कोस थीटा 1 आया था, वो चेंज इन पोटेंशियल एनर्जी हुआ। ये चेंज इन पोटेंशियल एनर्जी कहने का मतलब ये हुआ कि जैसे ये टॉर्क जो है, ये टॉर्क यहां पर पहले कुछ था, इसका पोटेंशियल एनर्जी थीटा 1 पर कुछ था, और फिर ये रोटेट करके मान लेते हैं कि इस तरीका से हो गया, ठीक है ना। तो अब इसका जो इसके साथ एंगल हो गया वो थीटा 2 हो गया, है ना। तो थीटा से थीटा 2 मीन्स ऑफ दैट थीटा से थीटा 2 गया। तो यहां से यहां जाने में जो हम क्या किए, टाउ ई एक्स टी लगाए तो वर्क डन किया होगा। तो थीटा 1 से थीटा 2 जाने में जो वर्क डन हुआ, यानी इसको वर्क डन किए वहां से, तो इसका जो जितना पोटेंशियल एनर्जी था वो यहां से यहां तक लाने में जो कार्य किया गया, तो उसका पोटेंशियल एनर्जी चेंज हो गया। पहले यहां कुछ था, यहां कुछ था, तो वो चेंज इन पोटेंशियल एनर्जी निकला, ना कि पोटेंशियल एनर्जी। अगर कोई पार्टिकुलर एंगल पर निकालना है तो चेंज इन पोटेंशियल एनर्जी के लिए हम यहाँ पर फॉर्मूला ला दिया आपको, Q इज इक्वल टू माइनस पीई कोस थीटा, मीन्स चेंज इन पोटेंशियल U2 माइनस U1। आप कंपेयर करके आप देख रहे हैं कि पीई कोस थीटा 2 माइनस पीई कोस थीटा 1 आ रहा है, ठीक है ना। तो इस तरीका से जो है आप इसको फाइंड कर सकते हैं इजीली वे में, कि कैसे एक्सटर्नल इलेक्ट्रिक फील्ड में जो है लगता है, क्या निकलता है, इलेक्ट्रिक पोटेंशियल एनर्जी। चलिए, that's all today. Next classes I will explain the force and acceleration of charge particle when it kept in electric field, and it is a start from rest. Charge particle start from rest. That is next classes we will find that is F is equal to QE, means of that F is equal to MA is equal to QE, means of that A is equal to QE by M. This is that. And next classes I will explain force, accelerations, and velocity. That's all. Today, आज के लिए बस इतना ही रखते हैं। अगले दिन फिर हम आते हैं न्यू लेक्चर के साथ। आप लोगों का लेक्चर कैसा लगा, आप वीडियो के कमेंट में करके आप हमको बताएं कि किस टाइप से और हम अच्छा से एक्सप्लेन आप लोगों के लिए क्या कर सकते हैं। कि इन ओनली, अगर आप लोग की अगर डिमांड हो कि ओनली हिंदी मीडियम में हो तो सिर्फ हिंदी मीडियम में करेंगे, या फिर ओनली इन इंग्लिश लेक्चर में, या फिर दोनों मिक्सअप हिंदी में लिखे या इंग्लिश में समझें। दैट्स ऑल फॉर टुडे माय डियर फ्रेंड्स और स्टूडेंट्स। थैंक यू।